Imagine you're driving down a really bustling downtown street,
Yeah.
and it's just pouring rain.
Oh, yeah, the absolute worst driving conditions.
Literally worst. So you're driving, and suddenly a delivery cyclist swerves out from behind this parked truck, totally hidden from your view.
Right.
But before your foot even twitches toward the brake pedal, your car has already slowed down. It anticipated the cyclist's path, and it smoothly adjusted your lane position.
And you didn't even do anything.
Exactly. I mean, you didn't do a thing. The machine it just knew.
Yeah, and that's the thing. For years, we talked about artificial intelligence as this, like, distant, shiny sci-fi concept, something that was perpetually a decade away.
Always 10 years out.
Always. But today, we are cracking open a stack of really fresh updates from an AI news digest. This is dated June 24th, 2026. And the reality is that the distant future is, well, it's already running quietly in the background of your morning commute.
It really is. It's an incredibly profound shift. We aren't just theorizing about algorithmic potential anymore. The sources we're looking at today, they paint a very clear picture of an active, hyper-perceptive partner. One that's constantly decoding the physical and actually the emotional world around us.
Right. We're basically moving from AI as this, software tool on a screen to AI as an invisible infrastructure.
And that is our mission for today's deep dive. We're exploring how this evolution actually impacts you. Because, we aren't talking about dry text specs or abstract coding languages here.
No, not all.
We're talking about fundamental shifts in how you get to work, how your body's going to be healed, and even how we understand human creativity. And we're doing it all without the overwhelming tech jargon. So, okay, let's unpack this, starting with that physical, chaotic world that we navigate every single day.
Yeah, so the digest highlights a major breakthrough from a leading tech company in the autonomous vehicle space. And self-driving cars obviously aren't new. But what's fundamentally different in this specific update is a massive, quantifiable reduction in navigation errors within really complex urban environments.
And the really compelling part to me is how they're actually pulling that off. Because in the past, the big hurdle was that cars were programmed with these rigid if-then rules.
Yes.
Like if the light is red, stop. If you see a white line, stay inside it, which, works flawlessly on some empty highway in Arizona.
Yeah.
But downtown traffic isn't a math equation. It's total chaos.
Right.
You've got pedestrians staring at their phones. You've got erratic cab drivers, double-parked delivery vans.
Pigeons flying at your windshield.
Well, exactly, all of it. And rigid rules fail the moment the environment becomes unpredictable.
Right. And what this update details is a massive leap in probabilistic machine learning. It's being fed by this incredibly dense array of enhanced sensors, like LiDAR, radar, optical cameras.
So it's seeing everything.
It's seeing everything. The AI isn't just looking for lane markers anymore. It's essentially building a constantly updating 3D probability map of its surroundings. So it's calculating the velocity of that delivery van, mapping the body language of the pedestrian on the curb, and assigning a probability score to what they're going to do next.
It's kind of like the difference between a rookie teenager who just got their learner's permit and a seasoned driver.
Oh, that's a good way to put it.
Yeah, because, when you first learn to drive, you were terrified.
Oh, yeah, 10 and 2, white-knuckling the wheel.
Exactly. You grip the wheel, stare dead ahead at the bumper in front of you, and you just obsess over following the painted lines. You're super rigid. But as you get more experienced, your brain starts doing this, probabilistic mapping without you even realizing it.
Right, it becomes second nature.
Yeah, you see a ball roll into the street half a block away, and your foot just hovers over the brake because experience tells you a kid might be running right behind it.
And that's exactly it. The AI is finally graduating from that rookie phase. It's moving from following rigid geometry to reading the actual intuition of the street. And by processing all that sensor fusion in real time, doing the math on thousands of variables per second, it achieves a level of situational awareness that a human brain simply cannot match.
Because it doesn't get tired.
Right. It doesn't get distracted. It has no blind spots and no fatigue. The digest explicitly notes that this leap in intuitive interpretation is rapidly accelerating the timeline for mainstream, ubiquitous autonomous transit.
But, the ability to predict physical chaos isn't just happening on our city streets. That exact same predictive power is being turned inward, right, into the literal mechanics of the machines we rely on.
Which brings us to the skies.
Yes, the aerospace sector.
Right, because if an algorithm can interpret massive amounts of external data to prevent a car crash, it can absolutely interpret massive amounts of internal sensor data to prevent a mechanical breakdown.
Makes sense.
One of the standout updates here is a major commercial airline partnering with an AI startup to completely overhaul their approach to predictive maintenance.
Predictive maintenance. Not scheduled maintenance. I mean, that feels like a massive paradigm shift for aviation.
Oh, it completely upends the traditional model. Historically, aerospace maintenance has been highly scheduled and, frankly, reactive.
Like changing the oil in your car.
Exactly. You replace a specific valve after 5,000 flight hours, regardless of its actual condition. Or a mechanic physically inspects an engine just because a pilot reported a weird vibration. It's a system that's built on averages and historical fail rates.
Right.
But what this AI is doing is creating a real-time digital twin of the aircraft.
A digital twin. So it's monitoring the actual real-world stress on that specific plane while it's in the air.
Precisely. A modern jet engine has hundreds of sensors measuring thousands of data points every single second.
That's a lot of data.
It's massive. Thermal gradients, microscopic changes in vibration frequencies, hydraulic pressure fluctuations. Now, the human mind cannot look at a spreadsheet of 1,000,000 data points and see that, say, a 0.2% drop in oil pressure combined with a slight acoustic shift in the turbine fan means a bearing is going to fail in 3 weeks.
Yeah, no human is doing that math.
Right. But a machine learning algorithm can. It establishes a baseline of a perfectly healthy engine, and then it just constantly hunts for microscopic anomalies.
So it actually senses the failure before the failure even exists in the physical world.
Exactly.
And the airline is using this to swap out parts before they break, which the source notes is dramatically reducing unexpected groundings, which is, great for the airline's bottom line, saves them millions. But for you and me, it means fewer delays when we're trying to fly home for the holidays.
And if we connect this to the bigger picture, both the autonomous city driving and the aerospace AI show a really fundamental pivot in how human infrastructure operates. Well, for all of modern history, our technology has been reactive. We wait for the car to crash or the engine to start smoking, and then we go fix it. But we are now entering an era of proactive prevention. The machines are intercepting the disaster before the timeline even unfolds.
Okay, I hear that, but let me push back a bit here.
Sure.
So what does this all mean for the actual timeline of trusting these systems with our lives? Because sure, you can predict a bearing failure, and you can predict a pedestrian's movement, but the real world always throws curveballs.
It does.
Does predicting the failure make the tech foolproof, or is it just a vastly better safety net?
Well, it's an infinitely tighter safety net, but foolproof is a very dangerous word in engineering.
Right.
Physics will always introduce variables we can't completely control. A freak lightning strike, a massive sinkhole opening up out of nowhere. The goal of these AI systems isn't absolute perfection.
What is it then?
It's compressing the margin of human and mechanical error down to the lowest possible denominator. It's about making the environments you move through mathematically predictable.
Okay, that makes a lot of sense. You're essentially reducing the variance.
Exactly.
But let's take that concept of predictive pattern recognition and apply it to something vastly more complex than a Boeing 747. Because the digest shows this tech moving from the mechanical code of vehicles straight into the biological code of the human body.
Yes. We're talking about the realm of medical diagnostics now.
Specifically, diagnosing rare genetic disorders. The researchers in this digest have developed an AI model that's doing this with a level of accuracy that is, frankly, mind-blowing.
It really is. And to grasp the impact of this, you kind of have to understand the nightmare that patients with rare genetic diseases usually face.
Right.
The medical community calls it the diagnostic odyssey.
Odyssey is the perfect word for it. I mean, if you or your child has a rare, unmapped disorder, the symptoms might be totally disparate. You have a vision issue, a joint problem, and a digestive issue all at once.
Yeah.
So you go to an eye doctor, a rheumatologist, and a gastroenterologist. And they all run tests in their own little silos. They rule things out. You get misdiagnosed. You take the wrong medication.
Which just adds to the trauma.
Exactly.
Yeah.
This process can drag on for 5, sometimes 10 years. It's a decade of pure agony and uncertainty.
And the reason for that delay isn't medical incompetence, right? It's a sheer lack of human bandwidth.
Right.
A rare genetic anomaly might only present in a few hundred people worldwide. An individual doctor simply cannot hold the entire global database of millions of genomic variants and all their corresponding physical symptoms in their working memory.
No, it's impossible.
But the AI can. What's fascinating here is how the algorithm navigates high-dimensional data. It takes the patient's sequence DNA and maps it against their specific clinical symptoms, and then it simultaneously cross-references that against global genetic databases.
In like a fraction of a second.
Literally seconds.
It's doing this crazy multi-dimensional matrix multiplication to find the one microscopic error in your biological code that connects to the fact that, your elbow hurts and your vision is blurry.
Exactly.
Humans just can't do that math. And the result is that the agonizing 10-year journey gets condensed into days. Doctors get the exact diagnosis, and they can immediately pivot to highly personalized, targeted treatment plans.
I mean, it fundamentally changes the practice of medicine from an art of deduction to a true science of computation.
It's incredible. But, reading physical biology, analyzing DNA and RNA, that's still dealing with objective hard data.
Sure.
Like a base pair is either mutated or it isn't. But the digest shows AI stepping out of the hard sciences and wading into something infinitely messier.
Right.
It's getting into human emotion.
Yeah, this is definitely where the intersection of algorithms and humanity gets, well, pretty complicated. The digest covers a novel AI application that's currently being integrated into mental health therapy sessions.
And here's where it gets really interesting, and frankly, a little uncomfortable for me.
Oh, yeah.
Yeah, because this tool works by analyzing a patient's speech patterns and behavioral cues during a live therapy session to provide the human therapist with insights into the patient's emotional state. And I have to say, reading this, my guard went right up.
Why is that?
Because it feels incredibly invasive. I mean, therapy is supposed to be the most intimate, trusting environment you can possibly be in.
Absolutely.
I'm sitting on a couch, opening up about a deep-seated childhood trauma or severe anxiety, and there's a microphone feeding my voice into a server somewhere so an algorithm can grade my tone.
I get that.
Like, I know I'm stressed.
Yeah.
I don't need a machine telling my therapist I'm stressed. Where is the line between providing helpful medical data and a tech company eavesdropping on our emotional privacy?
That visceral reaction is entirely valid, and honestly, data privacy is the central debate in this field right now.
Good. I'm glad I'm not the only one.
No, definitely not. But we do have to look closely at the specific mechanism of how this tool actually functions. Because the digest is very careful to frame this as an analytical supplement, not some robotic judge of your feelings.
Okay.
It's not analyzing the actual content of your trauma, it's analyzing acoustic biomarkers.
Okay, what does that mean, acoustic biomarkers?
Well, think about what happens to your body physically when you experience stress or recall a trauma. Your autonomic nervous system kicks in.
Right, fight or flight.
Exactly. Your heart rate variability changes, your breathing gets shallower, and crucially, the microtension in your vocal cords shifts.
Interesting.
Now, a human therapist is highly trained to read body language and listen to your words, but human ears physically cannot hear a 2 hertz fluctuation in the pitch of your voice that's caused by an invisible spike in cortisol.
Oh, okay. So it's essentially like a stethoscope for the vocal cords.
That's a perfect way to look at it. The AI runs in the background, just measuring the prosody of your voice, the rhythm, the micro-hesitations, the tiny acoustic tremors. It's not sitting there saying the patient is sad. It's flagging the therapist on a screen saying, hey, when the patient mentioned their sibling 3 minutes ago, there was a severe acoustic marker of physiological stress, even though they were smiling.
Oh, wow.
Yeah, it catches the biological tells that the human ear just completely misses.
I see. So it's highlighting blind spots. It gives the therapist raw physiological data, but the therapist still has to provide the actual human empathy to know how to navigate that moment.
Exactly.
It's not a robot therapist taking over the session. It's just pointing to a spot on the map and saying, dig here.
You nailed it. The human practitioner holds the context. The machine just provides an extra layer of perception.
Okay, that significantly changes how I view it.
Yeah.
And honestly, looking back at the progression of this digest, it's wild.
It's a lot to take in.
It really is. We've seen AI decode the physics of a crowded street, the thermal dynamics of a jet engine, the genomic code of rare diseases, and now the acoustic biomarkers of human trauma. It is basically quantifying our entire physical and psychological reality. So, what happens when it tries to quantify the most intangible, distinctly human trait we have?
Ah, you're referring to the final section of the digest, artificial intelligence entering the realm of high art.
Yes. The digest details a collaboration between a very well-known, established artist and a tech company. They use a specialized AI to generate an entirely new, unique series of paintings. And to be clear, this wasn't just someone typing a prompt into an image generator and hitting print.
No, not at all. This was a deep algorithmic deconstruction of the artist's entire life's work.
How did they do it?
Well, the AI was trained exclusively on the artist's past pieces. It mapped their specific color palettes, analyzed the mathematical geometry of their brushstrokes, and identified the underlying thematic structures they favor.
Wow.
Yeah, it built what's called a latent space, basically a massive mathematical representation of the artist's unique style. And from that math, it generated novel compositions that the artist then interacted with and refined.
It makes me think of an aging veteran musician who's been touring for like 40 years.
Okay, yeah.
They know their own sound so well that maybe they've become a little predictable, or they're just stuck in a creative rut. And then they sit down in the studio with this brilliant, savant-like apprentice.
Right.
And this apprentice has obsessively studied every single note the veteran has ever played. They understand the underlying math of the veteran's genius better than the veteran actually does.
I love that analogy.
Thanks. And the apprentice says, hey, based on the harmonic progression you used in 1998, if we invert this chord and change the time signature, it sounds exactly like you, but it's something you never would have thought of.
Yeah. But this raises an important question, though, and it's one the art world is fiercely debating right now.
Which is?
If the AI is making compositional decisions, if it's suggesting the inverted chord or the specific brushstroke who is the artist.
Oh, that's tricky.
Because for centuries, we've defined art as the pure expression of human experience, right? It's human angst, human joy, human perspective.
Right, art is supposed to be the messy translation of the human soul. Machine doesn't have a soul, it just has, processing power.
Exactly. But if that processing power generates a piece of visual media that genuinely moves you to tears, does the source code matter?
That's a deep question.
The artist in the digest argues that the AI is simply the most complex paintbrush ever invented. It's a tool that just removes the friction between imagination and execution.
Right.
But critics argue that because the algorithm is actively generating novel ideas based on its mathematical mapping, it crosses the line from tool to collaborator. It fundamentally forces us to ask if creativity is a uniquely human spark, or if it's just a highly complex pattern of data that can be replicated and expanded by a machine.
Man, it really blurs the line between the creator and the tool. But honestly, as we wrap up today's deep dive, that line is blurring literally everywhere.
It really is.
We started this whole conversation by asking how AI has evolved from a futuristic concept into a daily reality. And the answer is that it's no longer a distinct piece of software you actively choose to engage with. It's atmospheric.
Yes, it is fully embedded into the fabric of our infrastructure. Being well-informed today doesn't mean knowing how to code a neural network.
Thankfully.
Right. It means simply recognizing that these invisible systems are constantly operating around you. They are calculating the velocity of the cars next to you, predicting the failure of the planes above you, sequencing the biology inside you, and analyzing the emotional resonance of the words you speak.
It's all working toward making the chaotic world we live in safer, more predictable, and highly customized to our needs. Which, is objectively incredible.
It is. But I do want to leave you with one final thought to ponder on your own, building off everything we've explored from this 2026 digest.
Okay, let's hear it.
We just discussed how AI can deconstruct an artist's entire history into math to generate their next masterpiece. And we explored how it can analyze the microscopic tremors in our voices to decode our underlying stress.
Right.
So what happens when we scale those two capabilities up to a global level?
What do you mean by that?
Well, could an AI intimately plugged into our collective human behaviors, constantly monitoring our daily anxieties, our economic stresses, and our massive databases of artistic output, could it eventually predict our cultural shifts before they happen?
Oh, wow.
Will the next great global art movement or the next massive societal trend be born organically from a wave of human emotion? Or will it be quietly initiated by an algorithm calculating exactly what visual or cultural input humanity collectively needs to experience next just to relieve our societal stress?
Oh, wow. Are we going to express our culture, or is the algorithm going to prescribe it to us? That is a profound and, frankly, a slightly terrifying question to leave on. But thank you so much for joining us on this deep dive into the AI News Digest. Keep asking those hard questions, stay curious, and stay informed. We'll see you next time.